May 26, 1991, Bangkok International Airport. Recently landed from Hong Kong, a Lauda Air Boeing 767 is preparing for its scheduled flight NG004 to Vienna. There was a crew change at Bangkok Airport, and the aircraft is being piloted by Captain Thomas J. Welch, 48-year-old, an American. A highly experienced pilot with over 11,750 flight hours. First Officer Josef Thurner, 41-year-old, an Austrian. Experienced with over 6,500 flight hours. There are 8 flight attendants working in the passenger cabin. 213 passengers board the aircraft. At 22:45 local time, the Boeing 767, named Mozart, begins taxiing and receives clearance to proceed to runway 21L. After receiving clearance for takeoff, Captain Welch advances the engine control levers and sets the calculated takeoff power precisely. 23:02, flight NG004 departs from Don Muang Airport in Bangkok. The estimated flight time to Vienna was about 10 hours. At 23:07, while Flight 004 was flying at an altitude of FL 110, 3,350 meters, the IKS monitors in the cockpit displayed a message Rev ISLN, indicating a malfunction in the reverse thrust system. This meant that in case of a system failure, the engine could enter reverse thrust mode, creating reverse thrust during flight. Since the message on the monitors was merely advisory, the captain concluded that it was just a warning system malfunction likely caused by moisture infiltration.
It's stopping, starting up again and shutting down. We passed the transition altitude of 1013 hectopascals. All right. What does the manual say about the error message? Additional system failures may cause thrust reverser activation in flight. All right, let's see. Should I ask ground personnel? What, sorry? Should I ask the technicians? Yes, you can ask. No, probably just moisture or something like that. Yeah, probably. But you know that doesn't really say anything. It's just a notification. Could be moisture inside. You need to slightly turn the control wheel to the left. All right.
At 23:17, when Flight 004 was flying at a speed of 828 per hour, at an altitude of FL 250, 7,600 meters, and 15 minutes and 1 second had passed since takeoff, second pilot Turner said, "Hey, reverser is engaged." And at the same time, the left engine suddenly went into reverse mode. A strong jolt suddenly pulled Flight NG004 to the left, causing a 25% drop in lift on the left wing and disruption in the elevator and rudder control. The cockpit voice recorder captured the sound of metal breaking. The aircraft became uncontrollable. The Boeing 767-300ER, weighing around 180 tons, entered an uncontrollable dive immediately after the thrust reverser was deployed. The pilots attempted to correct the situation by reducing thrust on the left engine and cutting off fuel supply, but the aircraft, already descending rapidly, had completely lost control. The cockpit voice recorder recorded the last words of Captain Welch.
Jesus Christ! Damn it!
Following this, the cockpit voice recorder recorded an increase in background noise followed by several loud impacts. The maneuvering loads caused by the pilot's attempts to regain pitch control, combined with the speed during the dive, exceeded the structural limits of the aircraft. At the 29th second, after the thrust reverser was engaged, and at an altitude of about 1,200 meters, the aircraft reached a speed of 1051 per hour and likely broke the sound barrier. The maximum speed value that could be recorded by onboard sensors was 0.99 Mach. Due to the tremendous stresses, the tail section of the aircraft broke off, followed by both wing engine pylons. The aircraft then crashed vertically into the ground and completely disintegrated. The wreckage of Flight NG004 fell into the jungle in the Futoai National Park area, 5.5 kilometers from the town of the same name near the Myanmar border. Rescuers arriving at the crash site found the body of Captain Welch in the pilot's seat. The aviation disaster of Flight 004 claimed the lives of all 223 people on board. As of 2022, the Lauda Air Flight 004 disaster remains the largest aviation catastrophe in Austrian history, as well as on Thai territory, and involving a Boeing 767 aircraft. In Austria, the Lauda Air Flight 004 disaster received widespread public attention. The owner of Lauda Air, Niki Lauda, personally traveled to Thailand to participate in the wreckage examination and investigation of the crash's causes. Due to the hot climate, the remains of the Flight 004 passengers decomposed rapidly, and the examination of personal belongings was significantly complicated by looting by local residents and even volunteers. No one could stop these people. They even took rings off the fingers of the deceased, Niki Lauda later said in an interview. Former racing driver and current owner of the airline, Niki Lauda, expressed dissatisfaction with Boeing's behavior. The company practically did not comment on the causes of the catastrophe, did not rush to improve the engine thrust reverser mechanism, and did not change the instructions for pilots in case of a similar error, although it was already clear at that time that the thrust reverser mechanism had a flaw, and it was still unclear under what conditions it manifested. But Boeing needed about 3 months for consultations with lawyers and to prepare an explanation for the catastrophe. Otherwise, it would have been flooded with lawsuits. Immediately after the burial in Bangkok of the last 23 unidentified victims, Niki Lauda flew to Seattle and arrived at Boeing's headquarters, where he demanded access to a Boeing 767 simulator to reproduce the same flight conditions as Flight 004. Initially, the Americans refused, but under pressure from the head of Lauda Air, they eventually relented. On the simulator, Lauda attempted to save the Boeing 767 from crashing when thrust reverser number 1 was engaged at an altitude of approximately 7,500 meters under the conditions of Flight 004, and none of the 15 attempts were successful. In the end, Niki proved that the pilots could not do anything. Boeing tested the aircraft for engine thrust reverser activation in flight, but did so at an altitude of 3,000 meters, and it turned out that in such conditions, the airliner remained stable and could be landed. However, with an increase in altitude, the effect of the engine thrust reverser became catastrophic, but for some reason, Boeing was unaware of this. Even after solid evidence of the cause of the catastrophe, Boeing did not rush to make any changes to the aircraft's design, although the engine thrust reverser defect could have manifested on any Boeing 767. Then, Lauda proposed repeating the experiment with an actual aircraft. The idea was to lift the aircraft into the air with only 2 pilots on board and make up for the missing weight with cargo. The airliner was supposed to reach the same altitude and speed as Flight 004, and then the pilots would activate the thrust reverser of one of the engines. Boeing claimed that this could not lead to a catastrophe, but they refused to conduct the experiment and immediately began developing changes to the engine thrust reverser design. Several months later, Boeing conducted tests in a wind tunnel using a Boeing 777 model since the 767 model was unavailable. The results, extrapolated to the 767's similar construction, were shocking. If thrust reversal occurs at a speed of 900 km per hour, the aircraft rotates around its longitudinal axis at a rate of 30 degrees per second. Even Boeing's chief test pilot could not stabilize such a runaway aircraft and crashed, fortunately only on the simulator. The Federal Aviation Administration, FAA, determined that the unintentional activation of reverse thrust during flight should not render the aircraft uncontrollable. The answer to this question lay in the cruising speed and calculation error. During certification, the thrust reverser was deployed at an altitude of about 3,500 meters at a speed of about 500 per hour. Each time, test pilots managed to stabilize the aircraft and land it safely. Then, the results of these flights were extrapolated by a computer, and the results were accepted by the supervisory authority. However, these calculations were simply incorrect. If the thrust reverser is activated at cruising speed of 900 per hour, the lift on the wing decreases by 25%, and the flow on the horizontal and vertical stabilizers is also disrupted, rendering the aircraft completely uncontrollable. As an immediate response to these investigation findings, the Federal Aviation Administration ordered that the thrust reversers of all Boeing 767 aircraft equipped with P and W Series 4000 engines be mechanically locked until Boeing made fundamental changes to the philosophy of the system and construction details. The same applied to Boeing 747 400 aircraft. All Boeing 757 aircraft had their electrical systems checked, and the thrust reverser solenoid was replaced. The same criteria were also ordered for Boeing 737 aircraft. In its final report, the Official Investigation Commission of Thailand concluded that the crew failed to regain control of the aircraft after the deployment of the thrust reverser, citing the unintentional opening of the thrust reverser as a possible cause of the catastrophe. The exact reason for the thrust reverser opening could not be conclusively determined.